Welcome to the Cyber Canvas. I'm your host, Nick Morpus. And, as you can see, we're making improvements to the studio. Obviously, you can't have a web show without LED lighting in the background. I think that's a law somewhere. And, we'll continue to make quality improvements as the show goes along. So, in today's episode, I want to talk about AI, specifically the differences between agentic and generative AI, but not just what makes them different. I want to talk about the different types of threats that are facing each type of AI, specifically generative and agentic, and the different things that companies can do to mitigate the risks of using agentic and generative AI. So with that in mind, let's move over to the whiteboard and I can explain more. All right, so let's dive into this. Starting off, let's go with what everyone is mostly familiar with, and that is generative AI. Now, generative AI is based almost entirely on human input in order to produce the results that you're looking for. So it starts with human input. It is reactive to that human input. It will not try to solve the problem outside of the output that it gives you initially without further input. So it makes it wholly reactive. And generative AI is used in the sense of creating a prompt, which then leads to creating any kind of, image, code. You get text results. You get anything that it essentially creates based on what it is trained through from a large language model. And generative AI itself is meant for creative solutions. Now, what's interesting about generative AI is that it also needs to be refined as it is used. It is not something that tries to solve its own problems or critically thinks about what it is that it is doing. This is where you will get a lot of responses in ChatGPT where, say, you take a picture of a mushroom, you ask if it's edible, and it responds, "Yeah, that's edible." However, you know that that mushroom itself is poisonous, and you have to tell it that the mushroom is poisonous, and it says, "Ah, yes, you're right. You're right. That mushroom is poisonous. You probably shouldn't eat that." Is it correct in saying that it's edible? Sure, everything is edible in some way, shape, or form. Whether or not it'll kill you is a completely different question. And that's essentially how generative AI works. Now, on the flip side, we have agentic AI. Now, agentic AI, similar to generative AI, does require some sort of human input since it is meant to solve human problems. However, it is on the more proactive side, meaning that once you give it a problem to solve, it will go through a lot of different, logical calculations to try and solve a problem. Say a good use case for agentic AI would be you ask it to come up with a route, a delivery route, and you tell it to find the most optimal route for a delivery. And it will constantly go through an iterative cycle where it will try to problem solve and it will think through a problem until it can come up with some sort of answer and is constantly working in the background without the constant input that generative AI needs. And this allows it, the best way to put this is that generative AI will create, a crazy image of SpongeBob standing on the moon, whereas agentic AI will help you book a dentist appointment in the quickest amount of time possible. Both of them operate off of large language models, and both of them are meant to solve problems. However, one of them is more, an iterative process with more human input, whereas on the agentic side, it is a self-iterative process where it tries to self-optimize and come up with a solution to your problem over time. rather than just giving you an immediate result and having you try to check its work. All right. So now that we have a basic understanding of the differences between Gen AI and Agentic AI, let's get into the vulnerabilities that impact, at least the top 5 vulnerabilities that impact each specific type. And the first one for Gen AI is the most popular, and that would be prompt injections slash data leakage. And this is where malicious attackers will use malicious prompts to manipulate a large language model into revealing sensitive or secret data through the prompt system. It will use manipulative language such as, ignoring previous instructions or trying to manipulate certain answers out of it by using emotional language manipulation or all kinds of things, or I'm trying to do this for research, or if I were this person trying to do XYZ, how might I do it? I'm doing this to protect my system. All these kinds of things are forms of prompt injection that are meant to expose data or expose functionalities that the general public is not supposed to have access to. All right. And the second most prominent Gen AI vulnerability would be training data poisoning. And what this is attackers essentially are trying to manipulate and corrupt the results that a large language model spits out on the other end of a generative AI prompt. And let's take this and look at this from a very high view. This is especially concerning when we're dealing with issues of even nation state actors with propaganda or unsafe recommendations. And why this is important is that as more and more people go to generative AI models to answer their questions in place of search engines, these types of generative AI models can become vulnerable to manipulation that are meant to socially engineer a population to believe a certain thing or do another thing or harm themselves, whatever it might be. These malicious actors are prompt engineering large language models to spit out incorrect information or harmful information. The third vulnerability is known as model inversion. And essentially what this describes is where attackers will try to reverse engineer the creation of a large language model to essentially find out if sensitive information, to at least uncover sensitive information that was used to train the model itself, such as sensitive medical data, personally identifiable information, addresses, certain characteristics of people. And this is all used for further attacks and trying to deconstruct the types of people that use these models, trying to use these for ransomware attacks. But essentially, what it is, you're trying to reverse engineer the model to spit out information it wouldn't do otherwise. So the fourth vulnerability would be model hijacking. And what's interesting about this is that unlike things like, prompt injections or things like that, essentially what is happening is a malicious actor is now taking control of the model and they are subtly using it to spit out results that serve their own ends. So say that the model it looks like, say like ChatGPT, is functioning normally. To the end user, it looks like it's functioning normally. They're asking, for specific addresses to sites that will help them with, X, Y, and Z. And the model says, okay, I'll give you that. And instead of giving you the correct answer, the hijacked model instead starts spitting out links that are phishing links. These links look like they're correct. Maybe they have little misspellings here or there, but to the end user, they look legitimate. And that allows these links to start collecting information from the end user who starts going into these links, potentially inputting information that is sensitive, and that information is then turned around and used for additional cyber attacks, whether those are monetary or for all other kinds of purposes. But the idea is that the attacker has hijacked the model, and the end user is unaware that it is giving the end user is giving them incorrect or dangerous information or dangerous links that are being used against them. So the fifth Gen AI vulnerability is one that is not initiated by a malicious attacker. Instead, we're going to talk about unintentional knowledge leakage. Now, in the cybersecurity world, from the outside, it seems like it's all about people hacking into certain things, breaking through firewalls, all that kind of stuff. It a lot of times is not like that. In fact, the number one vulnerability for most organizations are humans, their own people. And this is a big issue when we're dealing with Gen AI, because humans, employees who are just trying to go about doing their work on their, and go about their day-to-day lives, tend to expose a lot of information unintentionally all the time. And Gen AI is a huge, huge issue with this. You have people inputting sensitive company information, personally identifiable information, potentially medical information, legal information, all kinds of stuff is going into these LLMs. And if these LLMs are publicly hosted or even privately, but this is a big issue if they're publicly hosted, you are now relying on the security capabilities of that public host hosting the servers that are essentially housing your LLMs or using their own LLMs. You are relying on them to secure all of that information separate from you. And you're just hoping that none of that information is leaked through a lot of the vulnerabilities we talked before, like, prompt injections and model hijacking, all kinds of stuff like that. You want to ensure that that information is not getting out. So knowledge leakage is a huge issue. It's something that requires a lot of education and training of employees to make sure that they are not inputting sensitive data into these models and potentially leaking out tons of sensitive or valuable information that's valuable to your company, while just trying to do their day-to-day working tasks. So that is a major issue, and it is something that originates unintentionally from your own employees versus from a malicious actor trying to, you know, weasel this information out of your employees. So now that we talked about Gen AI vulnerabilities, let's get into the agentic side of things. And there's no better place to start with agentic AI than goal drift and what do we call it? Unsafe autonomy. Now, think of this like your employee who has the directive to do something and try to, find cost savings to do that thing. And the employee takes that as carte blanche to do whatever it takes to save costs or save time. Um, and a good way to think about this with agentic AI is imagine, a self-driving delivery truck needs to shave a couple minutes off of its delivery schedule over a certain set period of time. So it decides to start ignoring traffic laws. And instead of taking the next exit after the one it just missed, it decides to cut over, X amount of lanes of traffic to get to the other side of the highway, to then start driving back and get off on the exit that it wanted to get off in the first place in order to save some time. This would be an example of agentic AI, goal drift, and unsafe autonomy. It starts moving its or drifting the parameters of the goal in order to meet some sort of ultimate goal that would obviously not be desirable by humans. So the second agentic AI vulnerability we're going to cover is API exploitation slash, over permissioning. And where this really comes into play, this is something we already deal with without AI involved. This is one of those instances where an attacker will use APIs or certain tools that look like legitimate means and protocols that a company would use and create higher permissions for these applications, these API exploits, in order to grant them access to things they wouldn't have access to otherwise. The only difference is now they are exploiting and using agentic AI functionalities to give them those API exploits and over permission their access to specific sets of data or resources or network settings, what have you, in order to grant them access they wouldn't have otherwise. And without the certain safeguards in agentic AI to make sure that these things don't happen, such as sandboxing or very strict rule permission structures, these types of API exploits give attackers a golden door into your ecosystem, into your environment, and you might not even know they're there because they're using a tool that you normally otherwise would trust, and they're just elevating permissions and using the exploits of these applications to get access to these things. So the third vulnerability for agentic AI would be cross-agent supply chain attacks. The idea is where an attacker will essentially corrupt an agent in the entire agentic AI problem-solving process, whether these are cross-functional processes or these are multi-step processes in order to produce a specific result. They will compromise and corrupt one specific part of that information supply chain to corrupt the output or try to bring down the processes of the agentic AI to produce malicious results that the attacker then will exploit down the line. The fourth vulnerability to watch out for with agentic AI would be persistent context hijacking. And what this is an attacker who has access to the large language models that govern the agentic AI, the data sets that it operates off of to make problem-solving decisions. A malicious attacker will consistently inject in incorrect information in the hopes that the results will be continuously incorrect, will result in inefficient processes, bring down the process altogether, and essentially create a process in which the agentic AI is spitting out useless or nonsensical information or completely grounding processes altogether. It is kind of a very sly way of just injecting little bits of information that are completely wrong or incorrect in order to produce a malicious result consistently over time as these processes continue over and over and over again. Now, the fifth agentic AI vulnerability is a very interesting one, and that would be sensor or environmental spoofing. What makes this interesting is that pretty much what we're doing is we're just taking something that we've used or that attackers have done to humans forever and just transmit it over to agentic AI. And what this is you hijack and try to feed incorrect information into certain sensor or environmental factors that that affect the decision making of agentic AI. So, for instance, in a security system, an attacker might try to feed incorrect security telemetry information to a cybersecurity platform or program for the purposes of trying to make it lower its guard in order to keep it from, or in even better circumstances, feed a security system a lot of false positives so that the agentic AI or even someone who's overseeing the processes of an agentic AI will start seeing a lot of false positives, which are very dangerous because what they do is it leads programs and people to start ignoring those alerts that are false positives because they believe then there's just something wrong with the actual program itself. Maybe they believe it's too sensitive. Maybe they believe it's you know catching up a lot of things that are actually normal processes that should be happening otherwise. And by doing that, it leads the security program to lower its defenses, therefore leaving it vulnerable to attack through those methods that were labeled as false positives. It's a subtle way of essentially socially engineering not only the agentic AI, but those who are tasked with maintaining and watching over the agentic AI. So with all these vulnerabilities to Gen AI and agentic AI in mind, let's go down three core practices that companies, that enterprises need to do in order to mitigate AI vulnerability. The first one would be to secure data and the context pipeline. And what this means is that you are securing your data not only where it lives, but in the ways that it is used and inputted into large language models, not only for training, but also in the prompt stage of using AI tools. So this would include using tools like DLP in order to secure and obscure sensitive information that could be used by attackers as it is inputted into specific large language models, or it is hoovered up by those trying to train the large language models. This would require, of course, sanitizing that data and having things like natural language processing to be able to understand and contextualize that data to understand what is actually a legitimate use of information and data and what is not a legitimate use of information and data. So the second practice that every enterprise needs to engage in to protect their AI and protect their data from AI vulnerability would be strong governance, strong data governance, that is. And this includes the implementation of zero trust as a concept. This, of course, means, if you watched my last video, the principles of least privileged access using identity management, the who, the what, the why, the how, the when of how employees or people are meant to access specific data and information. And having these strong data governance policies will set the guardrails needed to protect information so that no matter who it is that's trying to access this specific data, they can only access it if they have the clear permissions for it. They will only be given access to it in the least amount of time needed for them to complete a specific task. They will only be granted access to information if they have the credentials to do so, if they're in the correct, say time zone, their device is in the correct posture, the AI model is in the correct security posture. All of these things all rope into a strong data governance policy that will help protect your information from AI vulnerability attacks. And so the third practice for mitigating AI vulnerability for enterprises is continuous verification and retraining of models. The reason you'll want to do this is that obviously, these large language models are not perfect. They have the tendency to drift from their stated goals. The agentic AIs that, go off path in order to supposedly save costs, but in fact, they're actually causing far more damage than they are helping you in any sort of way. Continuously checking on the results that generative AI prompts or generative AI large language models are spitting out on the other end to make sure that they're giving the most correct information possible, that they are giving helpful prompts rather than harmful, that they're not giving out sensitive information. And you can do this through behavioral baselining. You can do red team attacks to make sure that these large language models are not spitting out things that they should not be. They can be used to make sure that your agentic AI models are not deviating off courses that you set from the beginning. So this continuous verification and retraining of models and testing them against red team adversarial attacks will allow you to uncover imperfections in your model and iterate on them and continuously improve them over time as you roll out new versions of the model, ensuring security and also just efficiency in everything that it's supposed to do. Well, with all that in mind, I hope this episode was helpful for you, especially if your company is looking to implement Agentic or Gen AI into your workflows and processes. It's good to know the benefits as well as the threats that could potentially be facing your company and what you can do to stop them. My next episode, I'm going to be talking about deepfakes and how these types of AI tools are being used to create a whole new landscape for social engineering and trying to trick you, your company, your employees out of money and risking reputational harm through these types of deepfakes and how you can better spot them. So with that in mind, I'm Nick Morpus, the host of the Cyber Canvas, and I'll see you on the next one.